Alright, so now we're going to deal with horizontal dilations. So that means if I have a function, what I can do is compress it or stretch it horizontally. So let's talk about how we find this. So normally the default period is 2 pi. For sine and cosine, it just takes 2 pi to go around one whole cycle. Okay. So describe how the graphs of following functions are related, then find the period of g of x and sketch one period of both functions on the same coordinate axis. Okay, so let's figure out what the period is. So for this guy, the period is 2 pi. Now for g of x, period is 2 pi over b. Here is my b, well, absolute value of b, but absolute value of 1/2 is 1/2. So 2 pi divided by 1/2. Instead of dividing by a half, I can multiply by the reciprocal, 2 over 1. So the period is going to be 4 pi. And so how do I know what my graphing region is? So for sine, we always graph between 0 and 2 pi for one period. So I set up an inequality. 0 is less than or equal to whatever is inside here. All right, so I have 1/2 x less than or equal to 2 pi. And by dividing by 2, I'm going to multiply by 2. Multiply all of my things by 2. I was looking at the wrong thing. Multiply everything by 2. So I have 0 is less than or equal to x less than or equal to 4 pi. So this is my graphing region. I want to go from 0 to 4 pi. So normally for our sine, just for regular sine, right, we have 0, max, 0, min, 0. So for sine of x, right, just a regular, our y values are going to be 0, max of 1, 0, min of -1, and 0. So for sine of x, right, just sine of x, this is happening at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's go ahead and let's graph 0 max, 0 min, 0. I have one whole cycle of sine of x. This is my f of x. Now, if I want to spread out my period from 0 to 4 pi, so for sine of 1/2 x, I'm starting at 0 degrees and I want to end at 4 pi. Halfway between 0 and 4 pi, this 0 is happening at 2 pi. Then halfway between 0 and 2 pi is pi. So at pi, I'm going to have my max, and at 3 pi, I'm going to have my min. So I start at 0, I'm ending at 4 pi. Halfway between is my third 0. Halfway between 0 and 2 pi is my max, and halfway between 2 pi and 3 pi is my min. So I'm stretching it out. So this is my g of x. Okay, let's try that one more time. Okay. So f of x equals cosine of 3x. So normally our period is 2 pi. So if I want to find out what my period is, it's going to be 2 pi over 3. So the period is 2 pi over 3, but let's go ahead and let's find our graphing region. 0 is less than or equal to 3x, less than or equal to 2 pi. If I divide every single side by 3, my graphing region is 0, less than or equal to x, less than or equal to 2 pi over 3. So I know that I'm going to be starting at 0. I'm at 0, and I'm going to be ending at 2 pi over 3. So let's go ahead and let's find what would be mid between them. Okay, so I'm going to list out. So for cosine, we'd go max, 0, min, 0, max. So here I know that my max is going to be at 0, and this max is going to be at 2 pi over 3, because this is my end and my beginning. Now this min is going to be halfway between 0 and 2 pi over 3. So I want the halfway point between 0 and 2 pi over 3. This is where I'm starting. This is where I'm ending. And so let's see. If I have half of 2 pi over 3. This means my minimum is going to be at pi over 3. Okay, and then if I want, let's see, halfway between my max and my min, where is this 0 going to be? It's going to be halfway between 0 and pi over 3. So it's all equally spaced. So I want the mean, the average of 0 and pi over 3. So this is how I find what's exactly in the center. I add the 2, and then I add them both up, and then I divide by 2. So I have 1/2 of pi over 3. So this is going to be pi over 6. And then if I want halfway between pi over 3 and 2 pi over 3, well, halfway between pi over 3 and 2 pi over 3, so this is just halfway of, let's see, 3 pi over 3 is pi. This is going to be pi over 2. So if I would graph cosine, right, my regular cosine function, start at max, 0, min, 0, max. Now, my function cosine of 3x is a little harder, so I'm starting at 0, right? My max is at 0, and then I have another max at 2 pi over 3, so it's 2/3 the way to pi. So like this is 1/3. Let's see. Let me zoom in a little bit. So let's see, maybe like this is 1/3 and this is 2/3 or so. So I'm going to have another max at 2/3 pi. 2/3 pi or 2 pi over 3. So right here is my other maximum. And halfway between them, I have my minimum at pi over 3. So I zoom in a little bit, right? This guy is 1/3 pi. This is 2/3 pi. And then this is 3/3 pi, aka 1 pi. So I'm greatly scrunching it in, right? I should be able to fit 3 of these cosine graphs in the space where it took me to draw 1. All right, halfway between 0 and pi over 3, I have my min. So halfway between here is my min, and then halfway between these are my other min. So it looks something like that. So it's greatly scrunched in. So it might have been easier, at least for this one, to go by like pi over 6 for my graph. So I can do that. I'm going to draw the graph down here and show you another way you could draw. So I would like this to be pi over 6, and this would be like pi over 3, 2 pi over 3, pi. Let's see, this is pi and 1/3, so 4/3 pi, 5 6/3 pi. So this is, no wait, this is 5 pi over 4. So I can't even fit a whole regular cosine function on this graph. But if I would draw, it makes it much easier to do my cosine graph, because then each of these vertical tick marks has a point on it. And then if I draw my regular cosine, let's see, pi over 2 is here, right here, and then down. Let's see, 5, 8, 9. Okay. So this is like what, if I would stretch out my graph, this is the start of my cosine, right? This is cosine of x. I just stretched it out. So ideally when you're graphing, you want to change these axes so every single tick mark is like where one of your angles is that you're solving for. Okay, let's throw a harder one in. So I have 2 cosine of 2x. So the period here, remember it's 2 pi over b. So my b is 2. So if I have 2 pi over 2, the period is pi. If I want to find out my graphing region, I said 0. So normally the period for cosine is 2 pi. So I'm just going to set whatever is inside these parentheses between 0 and 2 pi. Divide by 2 everywhere. So my graphing region is between 0 and pi. Okay, so I like writing this out so that way I know like where, like which angles am I going to use. So I'm going from 0 and my max is pi. Halfway between 0 and pi is pi over 2. And then halfway between 0 and pi over 2 is pi over 4. And halfway between 1/2 and 1 is 3/4, so 3 pi over 4. So this tells me where all of my angles are going to be located for my max, my 0, my min, my 0, and my max. All right, so notice that my amplitude is 2. All right, we have an amplitude of 2. So instead of starting at 1, I'm going to actually start at 2. So I'm going to start at 2, and then let's see, at pi over 2, I'm at 0. Nope. Let's see. I should say pi over 4. So at pi over 2, I'm at my minimum. So halfway between, and there's my max. So normally cosine would look like this. So max, 0, min, 0, max. So not only did we stretch it out, we stretched it vertically, we compressed it horizontally. All right, so frequency is just the reciprocal of period. So 1 over period, aka, well, if period is 2 pi over b, then we know frequency is going to be b over 2 pi. And I put parentheses, absolute value around the b. Okay, so find the period and frequency. So there's a 1 in front of here. So if I want to find the period, all I have to do, all right, so b is 1. Period is going to be 2 pi over the absolute value of 1. So it's just going to be 2 pi over 1, which is 2 pi. And so the frequency is going to be 1 over 2 pi. All right, this is what my script f is frequency. All right, so period here, b is 4. So period is 2 pi over absolute value of 4. So that's just pi over 2. So this means frequency is going to be the reciprocal of that, which is 2 over pi. Awesome. All right, phase shift of sine and cosine functions. So phase shift is literally you're having a horizontal shift. So it's similar to our y equals a times x minus h squared plus k for a parabola, where h is the horizontal and k is the vertical shift. It's similar to how we would have x squared versus x minus 2 squared versus x squared minus 2. All right, these are all, so x squared plus 2. So this would be going up by 2. This one would be going right by 2. And this is in comparison to our parent function x squared. So if x squared is here, x minus 2 squared would be 2 shifts to the right, versus the x squared plus 2, it'd just be shifted up by 2. So understanding horizontal shift, which is our phase shift, how we find that is just negative c over absolute value of b. So I could have a number in front of x, and then I could be adding. This is why I was kind of sketchy when I was talking about, well, yeah, c deals with your horizontal, because it also depends on the number in front of b, and in front of x, because if we're changing our period, we might not be scooting over as much as we think. So if I have y equals sine of 5x plus 2, this 5 is my b, this 2 is my c. So if I would set this equal to 0, I could find the phase shift. So if I set 5x plus 2 equal to 0, subtract 2 on both sides, my phase shift is going to be negative 2/5, aka negative of c, which is 2, over absolute value of b, which is 5, so negative 2/5. Either way, you get the same answer. You could either set bx plus c equal to 0 and then solve for x, or you can use the equation since you have your notes for the test and the quiz, and it's open notes, you can always use those. Okay. So, phase shift moves the graph horizontally either left or right. So graphs with horizontal or phase shift. So state the amplitude, the period, the frequency, the phase shift of each function, then graph. All right, so amplitude is the number in front. That's just going to be 2. The period is 2 pi over absolute value of b here. our b is 1, so it's just going to be 2 pi. Frequency is the reciprocal of period, so 1 over period, so this is just 1 over 2 pi. So frequency tells you, I think I skipped over that pretty fast. So frequency just tells you the number of cycles in 1 unit interval. So for instance, for sound, you can talk about hertz. So it's how many waves per second. So its frequency is 1 over 2 pi. So it's how many wavelengths per unit. So it's just a reciprocal period. And then phase shift. So I'm going to set x minus pi equal to 0, solve for x. Our phase shift is pi. Or I could say negative c over b. So negative, my c is negative pi, over b is 1, so negative of negative pi, negative times negative pi is pi, over 1, which is pi. So there's the two ways, either set it equal to 0 or use the equation. All right, we have everything that we need. So I'm actually going to change, no, I'll leave this on here, it's fine. Okay, so I want to know, where do I start graphing and where do I end graphing? So I set 0 is less than or equal to x minus pi, so whatever's in the parentheses. And like normally for sine, we go from 0 to 2 pi, so that's what I set my bounds as. If I add pi everywhere, so I'm just solving for x in the middle by adding pi everywhere. I'm just shifting everything over by 1 pi. That's all I'm doing. And then I'm going to be multiplying by a factor of 2. So if I start at pi and I end at 3 pi, let's see, sine starts at 0, max 0, min 0. So at pi and at 3 pi, I'm going to have 0. So pi, 3 pi. Halfway between, so at 2 pi, I'm also going to have a 0. Halfway between pi and 2 pi is going to be 3 pi over 2. So I'm going to show that, right? So halfway between pi and 3 pi, this is just half of 4 pi, so that's 2 pi. That's how I found the first. So I have my two endpoints, and then I find the part right exactly in the middle. And so this is the middle, and then I'm going to take the middle. So I found the middle first, and then I'm going to take the middle here to find the middle, basically taking the averages. So 1/2 of pi plus 2 pi is just 1/2 of 3 pi, which is 3 pi over 2. And then you could do the same thing for the last one. 1/2, so if I want to find the middle between 2 pi and 3 pi, add them together, so I want to know what's half of 5 pi. Well, this is just going to be 5 pi over 2. So let's see. My amplitude is 2. That's it. So if my max is normally 1, I'm going to multiply by 2 for a max of 2. If my min is normally -1, I'll multiply by 2 to get a min of -2. So this is what my function is going to look like. And that's it. Okay, perfect. All right, last one. So let's list out all again. Feel free to pause the video if you want to give it a shot yourself. Amplitude is 4. So the period. Period is going to be 2 pi over absolute value of b. So this is my b. It's literally 1/2 times x. X over 2 is the same as 1/2 x. So I'm going to divide by 1/2. Instead of dividing by 1/2, I can multiply by the reciprocal, 2 over 1. So the period is 4 pi. It's going to be spread out more. And the frequency is just 1 over that, 1 over 4 pi. And then phase shift, I'm just going to set whatever, I'm going to set my bx plus c equal to 0 and solve. So subtract pi over 3 on both sides. Now multiply by 2. So my phase shift is -2 pi over 3. To figure out where the heck I'm supposed to be graphing, I said, let's see, normally for cosine, I'm between 0 and 2 pi. So I set whatever is inside my parentheses between those, and then solve for x. So I subtract pi over 3 everywhere. So I'm subtracting pi over 3. So if I have 2 minus 1/3, that's going to be, you know what, let me show a little more work. So I'm going to subtract pi over 3. So I have negative pi over 3 less than x over 2 less than equal to, okay. So I have 2 pi minus pi over 3. Need to make a common denominator. So I have 6 pi over 3 minus pi over 3. This is going to be 5 pi over 3. AKA, if you have 2 pi, if you have 2 and you're minusing a third, it's going to be 1 2/3. So 5 pi over 3. And then lastly, I need to multiply every single thing by 2. Multiply 2, multiply by 2, multiply by 2. And so I'll get negative pi over 3 less than equal to x less than equal to 10 pi over 3. So I need to change my tick marks. So this is how we do it, right? So for cosine, let me list out. So cosine starts at a max, then a 0, min, 0, max. Let me make sure we're not flipping, so we're good. So we're gonna have a max, 0, min, 0, max. So my max is gonna be at negative 2 pi over 3 and at 10 pi over 3. To figure out the middle, right, the first middle part, I'm going to take the average between negative 2 pi over 3 and 10 pi over 3. So if I add these together, I have 1/2 times negative 2 plus 10 is 8 pi over 3. So this is just going to be 4 pi over 3. So I'm figuring out what angle each of these are going to be located at. I would like to start at, let's have this right here be negative 2 pi over 3. And then I'm going to count out 1, 2, 3, 4th tick mark over is going to be my 10 pi over 3. So I don't need these other tick marks because now we're not just nicely graphing. We've got some crazy stuff going on. Halfway in between, this is my 4 pi over 3. So I have my first tick mark, and then I have 1, 2, 3. The 4th tick mark over is where I label this. All right, halfway between these two, between 2 pi over 3 and 4 pi over 3. So I'm going to add them. So I have 1/2 of negative 2 pi over 3 plus 4 pi over 3. So this is 1/2 times 2 pi over 3. So this is just going to be pi over 3. And if I take the last one, I have 4 pi over 3 plus 10 pi over 3. I'd like to find the halfway point. So half of 14 pi over 3 is going to be 7 pi over 3. So we're stretching out this by, we're stretching out our period. Instead of being 2 pi, we're now making it 4 pi to go 1 period. But then we're also going to be stretching it, so it's not just 4 pi, it's going to be up 4 and then down 4 to 4 pi. It's stretching vertically. But then we're also shifting it over. So there's multiple things going on here. Okay, so I now know all of my values. All right, so this is pi over 3. If this looks a little crazy, you don't have to like write out every single one. Just write out maybe every other. So my max for cosine is 1, but because I have this 4, my max is now going to be at 4. Then a min of 0 at pi over 3. Then I have a minimum at 4 pi over 3. So at negative 4, because I am stretching out by a factor of 4, my amplitude is 4. So where my values used to be 1, 0, negative 1, 0, and 1, multiply by 4 to find the new y values. And then I have so these are my y values. These are my x values, so I could make a t-chart. So at negative 2 pi over 3, right, I'm going to have a y value of 4. At pi over 3, I have a value of 0. 4 pi over 3, a value of negative 4. 7 pi over 3, a value of 0. And then lastly, at 10 pi over 3, I'm going to have a value of 4. All right, so this is what my function is going to look like, and this is it for this screencast.